Sections 3.1 through 3.4, dealing with Galileo and Newton's ideas about inertia. The thinking up to this time, for a long time, had been that you needed to apply a force to an object to keep it in motion, because that was everybody's everyday experience. If you have a ball rolling along a table, here's a tabletop, here's a ball. If it's rolling along the table in that direction, it's going to slow down and it's going to come to rest and be not moving at all. And for millennia, people believed that this was because the natural state of motion of something was to slow down and stop and be at rest. It was Galileo that realized that the reason things slow down is because of friction. We actually have an unbalanced force on a rolling object with friction in the opposite direction to its velocity, so that it slows down. If you didn't have friction, the ball would just keep rolling forever. Remember the idea of dynamic equilibrium? If all we've got acting on the ball is the weight pushing down and the support force, the normal force, pushing up, no net force, we're in equilibrium. We either keep moving if we're moving, or we stay at rest if we're at rest. And Galileo had two important arguments for this state of affairs, that friction was slowing things down. His first argument was that a ball on a ramp accelerates. It goes faster and faster as it rolls down the ramp. If the ramp isn't quite as steep, it doesn't accelerate quite as much. It doesn't increase its speed by quite as much in the same amount of time. Similarly, if a ball is going up a ramp, up a steep ramp, it slows down rapidly, turns around and comes back. On a more shallow ramp, it doesn't take as long. So gravity is a force that's pulling strongly downhill on a steep ramp, not so strongly on a shallow ramp. And similarly, when you're on the way uphill, gravity is slowing you down, either a lot on a steep hill or not as much on a shallow hill. But nonetheless, downhill, being pulled along and increasing in speed, uphill, being pulled backwards against your motion and decreasing in speed. Galileo's realization there was that if you're on neither an upward slope nor a downward slope, but on a level surface, gravity has no effect in the left and right directions. Gravity pulls you straight down. And that force isn't going to tend to change your motion in the horizontal plane. So you're just going to keep moving. If there are no other forces acting, you just keep moving. And that's the idea of inertia. If you're at rest, you stay at rest. If you're in motion, you keep moving. If there's any kind of frictional force, then you're no longer in equilibrium, because this frictional force is a net force, an unbalanced force that's slowing you down. Galileo's other argument along the same lines dealt with a down ramp, a level section, and then an up ramp. If you start a ball from here, it's going to roll down the hill, getting faster and faster. It's going to roll across on the level surface, and then it's going to go uphill and slow down until it reaches its original height. Now, this would be in the absence of friction. If there's any friction, friction is an extra force that's always slowing the ball down, so it wouldn't quite reach as high. But with no friction, it gets back as high as it was before. If the uphill ramp isn't quite as steep, it takes a longer distance to reach the top. We accelerate downhill, we head across, we slow down on the way uphill, but it takes longer and the ball travels further along the ramp than it did on the steep ramp. Taking that to its logical conclusion, if the second ramp is level, it's got to travel an infinite distance forever in that direction to get back up to this original height. And so it's going to just keep rolling forever. And that leads to that idea of Newton's first law, that an object at rest remains at rest, and an object in motion remains at motion at constant speed in a straight line unless an unbalanced, a net force, acts on it. And this ties directly in with those ideas of equilibrium that we've already talked about. Objects in static equilibrium are at rest and have no net force, so their motion doesn't change. Objects in dynamic equilibrium are moving, but because there's no net force, their motion doesn't change. They keep moving at constant velocity.